Recording this session. All right, so let's go ahead and talk about a few things. Take a screenshot. Okay. So let's talk about similar polygons that are triangles. Of course, you all know this part. Polygons are with the same angle but different sides, and that's actually proportional sides. Corresponding angles are congruent, while the corresponding sides are proportional. The ratio of the corresponding sides are always proportional, and ratio of the corresponding sides is called a scale factor or a common ratio. Go ahead and put down common ratio also. I think it's 2 M's. Okay, so the first type of similarity that we have is something called angle-angle similarity. So this means right here, we have two corresponding angles, like this corresponding angle is congruent to this one, and this one is congruent to this one over here. If two triangles, okay, so if you got congruent angles like this, then the two triangles are similar. And this is also called AAA because it's AAA similarity. And if you notice, if you have two angles that you know that are same, then you can find out what the third one using the fact that the sum of the angles is always, the chat gets, okay, so we had a question about the chat, whether that gets recorded also. No, it does not, but it does get recorded. When I turn off my computer, when I turn off the session, it'll automatically save those messages into a separate file. So I do have access to that. Okay, just to let you know. All right, so 180 degrees and all that. So can these triangles be proven by AA or AA similarity? Well, on this particular triangle, we have that angle C and angle B are both congruent. So angle C and angle B are both congruent. Now we also need another angle. Now, this angle and this angle are vertical angles, so they're both congruent. So when we talk about this, we're talking about angle AEC is congruent to angle DEB. So those two angles are congruent. So we do have that. Now, on the quick check, which you can do on your own, you're going to be submitting this. You have to understand you have parallel lines. Once you have parallel lines, once you know about parallel lines, the cool thing is that you know something about these two triangles. Now, first things first, vertical angles, always congruent. They're the easiest thing to spot. Also, we have something called alternate interior angles, where K and G are the corresponding angles, but they're also congruent angles because of alternate interior angles. Okay, so we can say yes on that. So you're gonna have to describe that. Yes, these two triangles are congruent, and they're gonna be congruent according to this right here, or not congruent, but similar. Triangle AEC and triangle DEB. And that's how your statement for similarity is going to be. All right, now, let's go ahead and get this. Now, according to this, if we have similar triangles, then our sides are proportional, as always. So let's see, we're told that this angle, this side right here, AB, is parallel to CD. Okay, so that automatically tells you that this angle and this angle are going to be congruent. So then we have AA similarity based off of the fact that we have a vertical angles that are congruent. Now, we're told that AB is 4 units. AE is going to be this formula, 3x plus 1. Okay, so that's how we go ahead and mark those two. Then we have that CD is 8 units. And then we mark this as x plus 12. So we're going to solve this. First, we have to get the common ratio. So we know that AB and CD, or I should say DC, are our corresponding sides. So we get the common ratio for that one. So we have 4 divided by 8. So this is common ratio. And that simplifies to 1 over 2. So we use our common ratio to set this up. So now we take 3x plus 1 divided by x plus 12. Then we solve for x, because we're going to need that. So x plus 2 times 1 is going to be just x plus 2. Of course, we have 2 times 3x plus 1. We'll write this over here. We have x plus 2 equal to 6x plus 2. Subtract, let's see. Actually, that should be, I make a mistake. X plus 2. Yeah, and I made a mistake right here. This is supposed to be 12. I knew it. Wasn't coming out the way I wanted. Oops. Not 12 there. This is supposed to be 12 over here. So I'm going to subtract x from both sides. So 5x plus 12, but actually plus 2. I don't know why I want that one to become 12. So plus 2 is equal to 12. Subtract 2 from both sides. So we have 10 is equal to 5x. And of course, you divide both sides by 5. So x is equal to 2. That's what the x is equal to. Now, they don't want to know what x is. They want to know what the measurement of AE is. So AE is equal to 3 times 2 plus 1. So that's going to be 6 plus 1, 7 units. So that's 7 units. That's it. We did go over this in the last class, but we didn't go through the AA similarity. We didn't do ASA similarity or SSS similarity. We just talked about similar figures in general. Oh yes, we did talk about this. Now we have side angle side similarity. There's an included angle between the two sides. If the two triangles, if a pair of corresponding angles is congruent and the sides, including the angles, are proportional, then the triangles are similar. So let's go ahead and take a look at this. And this will go more towards what we were going over the last time. So right here, we have an angle, and these two sides include that angle on both of these triangles. So we already have an angle in common. So all we need to do is see if the sides are proportional. Okay? Since 6 is the smallest side on this triangle and 4 is the smallest side on this triangle, we can set up a ratio with that. So 4 over 6. And we see that that's equal to, and we have this side right here, 6 over 9. So we can either cross multiply or simplify. I'm going to simplify first. So this is 2 times 2. This is 2 times 3. I break these up into its common factors. This and this to 2 and 2, simplify to 1. What's left is 2/3. The 6, breaking up into its factor, have 2 and 3, and 3 and 3 for 9. These two will simplify to 1, and this becomes 2/3. Since the two ratios are the same, we can say that these two triangles are proportional, so therefore they're similar. Or you can use the cross multiplication just to check if that's congruent, that those two ratios are the same. So 4 over 6 equal to 6 over 9, we can check that. So 9 times 4 is 36, and 6 times 6 is 36. Okay. So these two are yes, and the similarity statement is MNL, and this one's going to be PRQ. Check the sound. All right, then finally we have something called side-side similarity. So on this one, we have 3 sides from the 2 triangles. So this would be the first side. These 2 sides are proportional, and these 2 sides would be proportional, this one and this one. Then we have a 3rd side. That's also there. So you're talking about the first one. Okay, what Mr. Vetta is talking about is that she found the common ratio of triangle TSU to triangle WXV. So basically, she just took a look at 3 and 9 and said, what do I multiply 3 by in order to get 9? So she decided to divide both sides by 3, so she gets x equal to 3. And that's her common ratio. But we have to check if all the sides have the same common ratio. So 3 times 5 gives us 15, yes. And 3 times 4 gives us 12. So this is all true. Or you can check it the other way. You can take 9 divided by 3 and see if that's equal to 15 divided by 5. And see if that's equal to 12 divided by 4. And all of them come out to be 3/1. And that's one, those are the 2 different ways you can do this. So this course, this is TSU, and this is WXV. So there's 2 different ways of doing it. Depends on how you find your common ratio. As long as you can find a common ratio and you can see the multiplications right there, the factors, you got it. That's fine. I don't care how you find it, as long as you find it. Now on this one, we can do it the same way. We can say, oh, we're going to go from this triangle to this one. What do we multiply 4 by in order to get 16? And if it works for all of them, then it works for everything. So x is equal to 4. Now, if you notice, the smallest side is 4, and the smallest side over here is 16. The next biggest side is going to be 5 and 7, and then the largest side for both of the triangles is 5 and 28. I mean 7 and 28. We check this scale factor with all of this. 5 times 4, does that give me 20? Yeah. And 7 times 4, does that give me 28? Yes. So yes, these 2 are similar objects. So we have triangle ABC and triangle XYZ. Oh, just got something. Just remember, the common ratio of triangle XYZ to triangle ABC, we're going to see what we're multiplying 16 by in order to get 4. So your scale factor is equal to, or the common ratio is going to be 1/4, which happens to be the reciprocal of the other one that we just get. So that's what happens. It depends what we ask for as a common ratio. What's the common ratio of XYZ to ABC? Well, it's 1/4. What's the common ratio of ABC to XYZ? Well, it's 4/1. It all depends. So you guys can do the quick check. This one is a little bit, it's easy. Okay, so we're going to be doing this. We need to see if these 2 are similar. remember, we have the similarity statements. We'll go ahead and just write them out. Side, 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 angle, side, or angle, side, angle, angle. Similarity. This is not congruency, this is similarity. Okay? So these two triangles are going to share this angle. So that means that angle X is congruent to angle X. So in this case, this angle, which is 80, is both equal on both of the triangles. Also, because that's equal to 80, that means that this side and this side are both parallel. Because they're both parallel, we can, well, there's a couple more things that we can make assumptions, but that's a little bit too much. But we definitely have AA similarity. So it's yes, AA similarity, and let's go ahead and name it by the information we have: XWV and XZY. Lots of fun, lots of fun, lots of fun. You guys want me to do B? Which is the similarity statement between these two triangles, please? All right, I'll do them. Yeah, I'll do it. Okay, so first off, you have this triangle. They have one common angle between them. So L is equal to L. In other words, here on this picture where they broke them apart into two different pictures, L is equal to L. Now, we don't have any angles, so we can't use let me see, we don't have any other angles, so we can't use angle similarity. You can't assume that KM and JN are both parallel, but they do give us sides. So they give us that one side is 6 on one triangle and the other side is 10. Then we have the length of the entire triangle from L to J, which is from here to here, which is 9, and from here to here, which is 15. So instead of writing 6 and 3 on this triangle, I just put 9. And instead of writing 5 and 10, I just go ahead and say that's 15. So I'm going to take 9 and divide that by 6. See if that's equal to 15 divided by 10. So if you simplify it, it's one thing. If you cross multiply, that's another. Well, let's go ahead and cross multiply. 6 times 15 is 90. And 9 times 10 is also 90. So yes, these two are similar because of that. So it's yes. And we did it by side, angle, side similarity. So it's side, angle, side. Can't be side, side, side because we don't have a third side. Can't be angle, angle similarity because we don't have any other angles. So it has to be side, angle, side similarity. Otherwise, it'd be none. No similarity. Oh, and the triangles, just to name it. I always start with the angle that they have in common. So KL, KM. And then there was LJN. Janine, or whatever it's called. How about C? Is C okay? Or should I let you guys do that one? Or shall I? Anyone care to guess the similarity? You want me to put this on a Nearpod? I can. Just takes me a few minutes. Okay, so Kenneth. Oh no, Kenya. What confuses you about this one? Just out of curiosity. I'm just waiting for a message. Okay, so you can say that there's certain similarity statements based off of the information you're given. So you can say whether the triangles are similar or not based off of whatever you're given. Now, the first one you have to try, and usually we have, is side, side, side similarity. We also have side, angle, side similarity. And then we have angle, angle similarity. So similar figures are figures that have the same angles but proportional sides, meaning things either get bigger from one picture to the next or smaller from one picture to the next. So on side similarity, we're just looking for a scale factor that you can take one of the triangles and multiply it by. So let's go ahead and take a look at this picture. So of course, we have these two triangles put together. I'm just gonna mark out my smallest side and my largest side, just to go ahead and mark it out. So I'm gonna highlight this. So the shortest side right here is this one, 3. And the medium side is this one. There's a reason why I'm marking those two sides and not marking the largest side. That's only for congruency. This is similarity. Similarity and congruency are two different things. Congruency, the corresponding sides are congruent or equal to each other. Similarity means that the sides can be changing a little bit. Yeah, that's always a confusing part. So we can say we either have congruency or similarity. So right now we're working on similarity, meaning that the pictures are similar. One can go for another, and then they're both either congruent or equal to each other. Okay, so we can talk about that, but we'll talk about that in a little bit. I'll go ahead and talk to you about that and then a little bit more stuff. So right here, we have this side, which is the smallest side on the larger triangle, and this side's the next largest. Okay, so we're gonna see if they are similar. They're always gonna have, sometimes when you put together the pictures, they're gonna be alike. But one, if you notice, the first triangle, CDG, the triangle CDG is smaller than the larger triangle, which is triangle EFC. Okay. That's okay. Happens. So we have two triangles, one's larger, one's smaller. This is actually a copy of the bigger triangle, which has dimensions. So we talked about this. This is 6, which is the smaller side. We'll go ahead and use using wrong things here. I'm gonna go ahead and put the highlighter. Okay, this is the small side on from the second triangle, which is the 6. And then 3 is the 3 from the smaller triangle. Then you have your medium size, which is the next side up, which matches 10. Now, there's a reason why I didn't want to mark the largest side is because the largest side on both of these triangles, because we have 6 right here and it corresponds to this 6 over here. Okay. But we can go ahead and say, oh, this side is the largest side of that triangle. So we have 12 units here. So because 6 plus 6 is equal to 12. And we can go ahead and check the scale factor. What do you multiply 10 by to get 5? So x is equal to 1/2. So that's the common ratio. That's half. So now we're going to check all the sides and see if they all have a common ratio of 1/2. So 10 over 5, well, 5 over 10, something like that. Because that's the way we go. If we just set it up with this right here, like 6 times x equal to 3, be 3 divided by 6. So we'd end up with 5 divided by 10. We can see if that's equal to 3 divided by 6, and see if that's equal to let's see, 6 divided by 12. And when we simplify all of these, they come out to be 1/2. So because they are similar, they multiplied all the sides by 1/2 in order to get the smaller triangle. If we're going from the smaller triangle to the larger triangle, they multiplied all the sides by 2. So if you multiply this 6 by 2, you get 12. multiply 5 by 2, they get 10. And if you multiply 3 by 2, that gives you 6. So yes, and the similarity statement is side, side, side similarity. Triangle CFE. Wow, I really botched that. And triangle, let's see, GDC. And that's your similarity statement. You guys are starting to see this? Let me go back to the first one, because I know I went really fast on that. When you see that they have an angle that is congruent, and they don't talk about anything about the other angles, but if you look at these two triangles before you cut into two, before you split the triangles apart, you have that X is congruent to X, or X is equal to X, because it's the same angle. So we have something called AA similarity. Once you know that that is true, you automatically know, hey, these two triangles are similar triangles, automatically. Excuse me. Now in the second part, they both share this angle L, and we found out that the sides are proportional, meaning if you take 9 times X, or some number, so 9 times X equal to 6, you get a proportion, well, a ratio of 1/3, no, 2/3, sorry. So if you take 15 and multiply that by 2/3, you get 10 automatically. Let's see, 15 times 2/3 times, control divide, 2/3, 10. So it's a scale factor. In fact, if I were to do this anyway, I know I'm going a little bit off the railing. So we had a side of 9, comma, a side of 15. And if you multiply that by 2 divided by 3, you get the other two sides, which is 6 and 10. All right. That's what we talk about in similarity. So on this one, for example, 7, we're trying to find the missing sides. So the first triangle we have right here, we have sides 3, 4, and Y. Let's see if I can remove that. So we have that triangle. That's just a smaller one. Then on the other one, we have these sides. So I'm going to try to copy this triangle, write down everything. So we have 4, 3, X, 3, and 8. Let me see if I can bring that over. Yeah, we can. So we have these two triangles. I need to decide, are these two triangles proportional? So taking a look at this, we know that this is a parallel line, that's a parallel line. They share this angle in common, so we at least know C is equal to C, which means this angle and this angle are both congruent. Then, because we have parallel lines, we know that this angle has to be equal to this one. Because of parallel lines, corresponding angles, so this angle is congruent to this one. So we have AA similarity. So that means that these two are similar figures. So we can go ahead and solve for certain things. Common ratio is the first thing I'm going to look for. So we have 3 and 4, so we add those together. So that gives me a total length right here of 7. So we can set up the proportion 7 divided by 3. That's going to be my ratio. Equal to, now I'm going to look for one of the other sides. So since we have x and 3 right here from the first triangle. We're going to add those two together. So we have x plus 3 divided by, and we have the 3 from right here, 3. Cross multiply, divide. So 3 times 7 is going to be 21. 3 times x is 3x plus 9. Okay, 3 times 3, 9, yeah. Now I'm going to subtract 9 from both sides. That gives me 12. Let me see. Make sure I have the right one. No, I do not. Sorry, I apologize. I made one little mistake. And that's with the common ratio, which is the biggest mistake that I could make. I was looking at this 3, I wasn't looking at this and this. So 4 corresponds to 7. So it should have been 7/3, 7/4. Apologize, I didn't see that. Cross multiply. So this is 21 equal to 4x plus 12. Subtract 12 from both sides. So that gives me 9 equal to 4x. And this is ugly, I'm sorry. Divide both sides by 4. So x is equal to 9/4. That's the ugliest thing I've ever seen. Ugly numbers. I don't not like that. Oh well, can't help it. Now, we go ahead and solve for y. So just checking this right here, the corresponding sides. Well, 8 corresponds to y. And we still have the common ratio of 7/4. So we have 7 divided by 4 equal to 8 divided by y. Cross multiply, divide. So 4 times 8 is 32. And 7 times y is 7y. Divide both sides by 7. 32 doesn't go into 7 very nicely, so I'm just going to leave it at 32 over 7. Just don't ask me about complex conjugates right now. Those are a little bit out there. I think that's about it. Yeah, that's it. I don't want to go over page 6 because that's a little bit involved. All right. A little bit. Okay. Okay. Let me take a look at, we'll go ahead and do this first. Let's see. Export PDF, or not CCF. PDF, and full page. We're only going to do the first 5 pages. Because you don't need everything. This one. This one. Yes, Tanner? Yes, Robert, what's going on?
My little baby is Angela, my little baby.
Robert, are you okay? Okay. Okay, so I got that. Okay, let's see if I can go ahead and do this. talk about this for a little bit. So here's a couple of problems. Do you want me to go ahead and go over these ones just to mumbling a song? Okay. All right. So do you want me to go ahead and show you a couple more examples with AA and SS and okay. All right. I'll do one more, two more examples. All right. So right here we have three types of similarity: side, 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 side angle, side, and angle, angle similarity. Okay. So we're gonna have to match up the sides. So I'm gonna match up the sides as small, medium, large. Okay, so the small side right here, 21 small, 10 is the medium. So right here, the medium right here is 30, and then this one right here. So we can see which sides match up, which sides are gonna match up completely. So 7 and 21, so you have to ask yourself, okay, so the 7, what times 7 gives you 21? Well, x is equal to 3 then. And you can see, you know, do all these have the same common factor? Can we multiply all these by 3 and get the next triangle? Well, let's see. 3
Excuse
times
me.
7. Yes, sir.
Emily wants to know if she could be excused. She has an appointment.
All right. Okay, so 3 times 10, 30. 3 times 5, 15, 45. So yes, it is by side, side, side similarity. Because we don't have any angles. We only have sides. And then you can name the triangles accordingly. So I'm going to name this R, P, Q. And then the other triangle is going to be, let's see, starts right here, O. Let's see, we said R, P, Q. So R, we want to across the longest side, so it's M, N. Okay, so yes, they are similar. Now, next one, we're going to be doing angle, angle, or side, angle, side, or side, side, side similarity. Well, here you just look at the picture. Well, there we have no side lengths, so that means that it's not going to be either one of these two. But they do give us two angles, but they're not the same. But we need to go ahead and talk about this right here. We're going to have to find out what this angle is and see if it's going to be the same as this 120. So 40 plus 120, well, that gives you 160. If you take 180 and subtract 160, that's 20. So this gives me 20 right here. So of course, this means this would be 40. So we have angle, angle similarity because we have two angles in common with the two triangles. So angle, angle. And you can name that accordingly. Let's say R, S, T. And we're going to try this with C, B, A. I did a little bit backwards, but that's okay. Is there any questions over this? Okay, so number 4, take a look at it. Think about it for about 5 seconds, about a minute. What do you guys think? Are these two triangles similar? Yes or no? Yes. Yes. Oh, we're getting a lot of yes. Are you sure it's a right triangle? No, I'm talking about this one. I'm talking about these two guys. Do they tell you you have right triangles out of curiosity? They look like right triangles. They look like right triangles. But are you told directly that these are right triangles? And this is a dangerous thing. Looks like it's very dangerous inside geometry. Well, they probably did because of being jerks. I'm going to tell you this right now. Being in geometry a long time, I've been a jerk, and I've done this before, but they look like right triangles. But having a right angle means making sure that for sure that these are right angles. But we don't, unless they tell you that this is a right angle and this is a right angle, you can't take that for granted. You can't. Unless they tell you straight out that angle Z and angle K are right angles, we can't assume anything about them. We're going to go off by what it has in the picture. So I'm going to assume that they're not right triangles. They could be 89 degrees. Z could be 89 degrees. K could be 91 degrees. And that looks very close to a right angle. I'm going to tell you right now. So right now, as it stands, these are not right triangles until they're proven otherwise. So since we don't have an angle in common with this, we can't say this is side angle side congruency. They look like they're right, but they're not. We don't know for sure. Not unless they tell you, oh, this is a right angle, this is right angle. Like right here on number 3, you can tell, if they didn't put this little mark right here, nor this mark to say that this angle and this angle are congruent, we couldn't say that those two are congruent angles. Looks like it's very dangerous. I'm going to tell you that right now. So these are no, they're not similar. Because remember, we have the 3 side, 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 angle, side, and angle, angle, similarity. We don't have any angles, so they don't tell us any angles. So we can't use either one of these. And then we only have 2 sides out of 3, so not enough. So this is no. Looks like it's right. It's dangerous. Don't ever, ever, don't ever assume that it's right. You can't assume that. If it is, then yes, that would have been two congruent. No, those would be similar triangles. So yes, if I did say, if they did put down a right angle for this one and a right angle for that one, oh yeah, you could go ahead and say, yeah, those two are right. So those are right triangles. That's only if they tell you. If they don't, let me try to find an example where they have that. Now, when they tell you that this is parallel and this is parallel, you know for sure that this angle and this angle are going to be congruent. The alternate interiors. Right. Never judge a triangle by its cover. Not unless they tell you everything that there is about it. Yeah, if they give you another number for the hypotenuse, let's go ahead and let's go ahead and take a look at that. Oof, this is awful. I'm taking a look at this right here. This is not a very nice right triangle, if it is a right triangle. And this is because of this. 10 squared, let's see, 10 to the second power plus 9 to the second power. And I take the square root of the answer. Oh, that's awful. 12.8 for a side? We want to. Yeah. That's an awful side. I mean, if you assume that this is the right angle, then this would be side A and side B. Same thing with this one. Oh, this is awful. This is awful what they did. Yeah. The apothem. No, wait a minute. You don't want to do apothems here yet. They don't give any right triangles. So let's go ahead and do this just to go ahead and give it out to you guys. Oops, that got changed. So you have two triangles right here. And I can guarantee you, I'm going to tell you this right now. This is the right angle, that's the right angle. And so now, this is 3, this is 4. Got a call coming in. A similar triangle based off of this would be, an easy one would be 6, 8, and 10. These two are similar. They're always going to be similar. That's a good similar one. That's because we know that the third side. So in this case, if we didn't have this disappeared. We're going from a smaller triangle to a larger triangle. That's going to be your similar triangles. And then we can have SSS similarity. But if I were to do this right here, like erase the hypotenuse, where we don't know. Right now, as it stands, we don't know anything about the two triangles. We only know that the two triangles, we have these two sides over here on the first triangle, and these two sides, we don't have enough information to say that they're similar. But if we put the 90-degree angle, then we can say they're similar, because we have a proportion of 2 to 1 from the first triangle to the second one for both of the sides. And we have that angle, so we have side angle side similarity. So I'm gonna let you guys do some work on it. Oh yeah, thank God, thank God, thank God. But you know what? If you need any help, I'll be here after school. I'm gonna change channels. I'm gonna go to another one. I'm gonna stop the recording right here. Yeah, and it has to start somewhere, guys. It has to start somewhere. Stop the recording.